Okay, so we're going to look at SHRATEY. So the notes that we talked about last time, we were talking about SHRATEY, which looks just like this. If you look at the SHRATEY steps, they're pretty much all the same. So R is still talking about the roots. So that's still setting the numerator equal to 0. The A still stands for the vertical asymptote. That's still setting your denominator equal to 0. That's the same. T is talking about the together or apart. It's still talking about the tangent, even though I didn't write tangent here. E is still your end behavior. If you think back to last class, we didn't talk about the top-heavy scenario whenever you have an oblique or slant asymptote. We're going to talk about that today. So we are going to talk about our top-heavy slant asymptote. When we have a slant asymptote, we're going to use long or synthetic division to actually simplify. And I'll tell you guys when to use long division and when to use synthetic division. And then the last step, of course, is to find the y-intercept, and that's by plugging in 0 for x. The two things at the top of the page are the only new pieces. We're talking about the S and H part of SHRATEY. So from here on out, I would probably recommend using SHRATEY instead of SHRATEY because it actually covers everything you need without having to figure out, wait, do I use the SH one or just the SHRATEY one? Just use SHRATEY from here on out. S stands for simplify. What I mean by simplify is I want you to factor your numerator and denominator and see if anything can cancel. If you can cancel something in the numerator or denominator, that's actually important. And it relates directly to H. H stands for holes. So if you locate any holes, you're going to find them by the factors that you cancel. You might have heard this back in your Algebra 2 class as a removable discontinuity. So now, the last part of rational functions that I'm going to review with you guys is how to find holes and how to find your slant asymptote. So in order to find your hole, the last thing is, whenever you're finding the hole of your graph or your function, you're going to take whatever's been factored, you're going to plug in the x value, use your simplified equation to find your y value. The goal when you have a removable discontinuity, which is a hole, is to get a coordinate. That coordinate is what I look for as your answer. So I'm going to actually circle that too. The goal of finding a removable discontinuity is to find an x and y coordinate. So we're going to take these steps that we've already pretty much been talking about. We're just going to add in a couple other pieces. And we're going to look at the packet that you guys have for SHRATEY. So go ahead and get your packet out. I'm going to kind of flip between both of them. Let's take a look. Remember, guys, there's methods to my madness. Let's look at question number 4 first. Question number 4 is this guy. Check your paper, make sure you have the right one. So over here along the side, I'm going to write SHRATEY. And remember, these are just the steps. This isn't anything new that I'm teaching you guys with rational functions. These are just the steps to help you graph your rational functions. So the S stands for simplify. Okay, in this problem, I need to see if I can simplify the numerator, denominator, maybe something will cancel. Let's try to factor that numerator. So over here to the side, I'm going to create a little X chart, and I'm going to try to factor. I need two numbers that multiply to 8, but add up to 5. Itzel, do I have two numbers that will multiply to 8, but add up to 5? No, we don't. So I'm going to put a big note in here. This can't factor. That's fine. The denominator is just a binomial. I definitely can't simplify that at all. So over here next to simplify, I'm just going to put done. You're done with it. There's nothing else you need to do. The next part is H. The only time you have a hole or removable discontinuity is if a factor cancels. Did we cancel anything over here? So we're going to put none. R stands for roots. Okay, if I look for my roots, I'm looking at the numerator. We're going to set that equal to 0, and we're going to solve. So we're going to take x squared plus 5x plus 8, set it equal to 0, and solve. Chelsea, can I factor this? No, we already said we can't factor. Okay, so how can I solve this? Because we have to find the roots. Quadratic what? Tell me. I'm gonna flip it over to the backside because it sounds like it's going to be a big thing. X equals negative b. Go ahead. What is that called, guys? Quadratic formula. You're on the right track. Quadratic formula. If you can't factor, you're going to still need to give me the x-intercepts. You can technically do one of two things. Either give me the quadratic formula, solve it that way, or use completing the square. You can use completing the square for any question, but honestly, quadratic formula for you guys might be a little easier. So I'm actually going to use the back of my page. All the backs of my pages are blank. I'm going to take x squared plus 5x plus 8. We're going to set that equal to 0, and I'm going to use the quadratic formula that Chelsea just gave me. So I'm going to make a equal to 1, b is equal to 5, and c is 8. X is going to equal negative b squared minus 4ac 2 times a. So we're just going to simplify. We're going to make this negative 5 plus or minus the square root of 25 minus 8 times 4 is 32, right? I sure hope so, unless math has changed. We're going to make this x equals negative 5 plus or minus the square root of 25 minus 32 is negative 7. Wait a minute, can you take the square root of a negative? I mean, you technically can, but what do you get? This is imaginary. What does it mean if something's imaginary? It doesn't exist. There's no real answer. So how many solutions will I have for this? 0. There's no real solution. So no real x-intercepts. And remember, x-intercepts are the same as solutions. So I'm purposely putting real in there because you could technically solve it for imaginary because you guys know the square root of negative 1 is I. You should remember that from algebra 2. We don't want to find the imaginary solutions. We're trying to graph a real rational function. So on the front side of the page, I'm going to flip this over, and I'm going to write for the r, for my roots, there are no x-intercepts, at least not any real ones that we can graph. A stands for my vertical asymptote. Looking back at my SHRATEY steps, A means that you're going to set the denominator equal to 0 and solve. So we're going to set x plus 3 equal to 0 and solve. X is going to equal negative 3. Valerie E, in that denominator, what's the multiplicity for this? 1. So what does that mean? It's going to what? What do you mean it's going to cross? No, it's not that it's going to be linear. Think back to this item here. When you have a multiplicity of 1, might be better to use the SHRATEY steps because it's more detailed. When your multiplicity is not 2, what do we have to graph it as? Apart. So over here, I'm going to write next to this that this is going to be graphed apart. So it's going to mean that the graph is going to go in 2 separate directions. You're not going to graph both ends at the same same direction. E is for your end behavior. Okay, so in your end behavior, even though it's not written on this page, it is written on your page that we have for regular SHRATEY. We need to check the degree for our numerator and our degree for the denominator. So in the numerator, Valerie E, what's the degree for your numerator for this problem? 2. And what's the degree for the denominator? Keep in mind, guys, even though she's absolutely right, it is 1, the degree and the multiplicity are not always the same. So don't think just because the multiplicity is 1 that the degree is going to be 1. I just want to mention that. This is new. This is now top heavy. There's a higher number in the numerator than there is in the denominator. when you have a top-heavy graph, you are going to have a slant asymptote. So over here, I'm going to write slant. There's going to be a slant asymptote for this. The way you're going to find it is by using long or synthetic division. I don't care which one you use. However, when using synthetic division, you can't use it for every question. You can only use it when it's a binomial that has a leading coefficient of 1 and a degree of 1. We already know that this has a degree of 1. We already know that. The leading coefficient in front of x is also a 1. So for this question, I can use synthetic division. If that's not the case, guys, use long division. Synthetic division can technically be used for any binomial, but there's one extra step when your leading coefficient is other than 1 that 99% of students forget to do. So I don't like to have you guys do it for that. So for this question, I'm going to use synthetic division. I know I need to set this equal to 0 and solve, but I've already done that. I already know that it's -3. So we're going to do -3, synthetic division. I'm going to take all of the leading coefficients from each of these, or not just leading coefficients, but all the coefficients for the trinomial and put them in here. Now I need to do a solve. I'm going to bring down, multiply, add, multiply, and add. I know this is my remainder. Does this remainder affect your slant asymptote? No, it doesn't. If you remember from Algebra 2, whatever the remainder is, it's not going to affect your equation for your slant asymptote. Your slant asymptote just needs a slope and a y-intercept. Especially for our class, we're just looking at linear slant asymptotes. Here's your constant, here's your x to the first power. So the slant asymptote that I'm going to use is y equals x plus 2. That's the equation for your slant asymptote. And then the last part is your y-intercept. So your y-intercept, I'm going to take the original function over here. I'm going to plug in 0 and I'm going to solve. So my y-intercept is going to equal 0 squared plus 5 times 0 plus 8. We're going to do 0 plus 3. 0 squared is nothing. 5 times 0 is nothing. So I'm just left with an 8 in the numerator. 0 plus 3 is just 3. What is 8 over 3 as a decimal? Because I'm going to have to graph this. 2 point what? 2.6. It's about 2.6 repeating. So I'm writing that out so that way you guys know what we're graphing. So I'm going to kind of slowly work my way to the left-hand side. Let's go ahead and graph since we have that in the middle of the page. All of the items that we have, let's graph them. In blue, I'm going to graph my asymptotes. We don't have anything to simplify. We don't have anything else to do. There's no hole. There's no x-intercepts. We have a vertical asymptote at -3. I'm going to make a little note that these need to be graphed apart. I have a slant asymptote. Your slant asymptote is at 2, or at y equals x plus 2. This is a linear function. How do you graph a linear, equation? How do you graph a linear equation? What do you start with? Okay, so the y-intercept is at 2. And then what? Rise over 1. What's the slope, though? 1. There's a coefficient in front of x, which is a 1, so you're going to go up 1 over 1. That's why you need a ruler. Remember, this is an asymptote, so if you're jumping ahead, first of all, you need to have all of these stupid points, guys. Don't just put a couple and think you're done. If you don't have all these points on tests and quizzes, I can't guarantee that you're going to have the right graph. When you graph all of those points, you're going to use your ruler to create a dashed line. The reason why I'm saying dashed is because this is not your function. This is just your slant asymptote. So to graph a slant asymptote, I always do it with a dashed line. That would be your line. So notice it's really just a bunch of circles, and I have it dashed throughout. Dashed line because it's an asymptote. Asymptotes, like we did for vertical and horizontal, you don't actually write out the entire thing with a solid line. You just graph it dashed. All right, so in pink, I'm now going to actually graph the y-intercept because I didn't have an x-intercept. So my y-intercept is about 2.6, which is right above that y-intercept. So now we need to think about how it's going to be graphed. Okay, well, this is my only point. We've already talked about asymptotes. You cannot cross these boundary lines. So it's going to probably go this way, towards that asymptote. And I need it to go here, but I can't just like shoot it up. We're going to go kind of curve it around and approach the other one. So I'm just curving it. Your graph should look something like mine. It doesn't have to be as close to the asymptotes as mine is, but you want to see that they're getting closer and closer.
You know, you draw over there.
How do I know I draw what? Okay, so it needs to be a curve, right? Just like how we've had before. This curve is going this way towards this asymptote. I need another part of the line to approach the other asymptote too. You have to have it approaching both. If you think back to...
No, I was saying like the different spot, like draw the line in a different spot, like the bottom, like quadrant 4.
Are you talking about down here?
Yeah, I'm talking about like, how do you know you're supposed to draw it over there? And that's
Because we had a y-intercept that was right here.
Oh.
That's the only reason why. When you have a y-intercept, guys, that's where that's the area that you're going to draw it. I don't care. So, Hussein, to answer, I guess, your question, if you were thinking of it, if you had the y-intercept down here, you would obviously draw the graph in this area. So wherever your point is, that's where you're starting it off. Since it says apart, this graph is already going up in this direction. So look at your asymptote. It's getting close to the x equals -3. It's going to this side. To make it apart, we're going to graph it down here. So it should be approaching this other quadrant. So notice that both of them are getting close, but they're not actually touching either of those asymptotes. All right, we're going to finish up a couple things. Melissa, what's the vertical asymptote here? We have it all written out on the right-hand side. Do we have a slant or horizontal asymptote? And what's that equation? Removable discontinuity is really just a hole. Do we have a hole for this? No, none. Melissa, what's the y-intercept? Okay, so I'm going to write that as a fraction, 8/3, because the only reason I wrote it as a fraction or decimal was to help you guys with graphing it. That's the only reason why. For your x-intercept, do we have an x-intercept, Melissa? No, there's none. And then for the domain, I'm going to be lazy. I'm going to put all real numbers except, what number are we not including for our domain?
-3.
-3. And you could also write it as x cannot equal -3. So I'm putting that in parentheses. For the range, I'm not going to talk about the range. Instead, because I know what I put on your homework, I want to talk about the point, or plural, of discontinuity. I sure hope I spelled that right. Points of discontinuity. When you're finding a point of discontinuity, I want you to look at your denominator. What a point of discontinuity means is it can't be undefined. So you need to identify to the reader, which is me, where is the graph undefined? So if you want to put in the parentheses, undefined, that's what you're trying to identify. Where is your graph going to be undefined? So on this graph, it's very similar to the domain. We already know that we have a vertical asymptote at x equals -3. The slant asymptote is not affected by this. So your point of discontinuity is just x equals -3. That's it. It's not a coordinate, it's just what are the x values that are not going to exist. All right, are we okay? This should be a review. This shouldn't be brand new to anybody. Yes, sir. Say it one more time.
If I'm like a quiz or test, I was for like all real numbers except for the domain, would that be kind of?
If I ask you to write it in interval notation, I would obviously take off a point. But if I don't specify to write it in interval notation, this is fine. This is perfectly acceptable. All right, let's look at example number 1. I'm only looking at 3 questions today on this packet, so now you know. Question number 1 will not take too long. For question number 1, I'm going to write SHRATEY along the side, and I want you guys to start simplifying. So try to simplify. If you need the back side of the page, it's there if you need it. This is just a review of Algebra 2. So Heidi, if I asked you to simplify the numerator, what can you simplify the numerator into? How'd you know? It's a difference of squares. With that being said, now that I've rewritten it in blue, can I cancel anything? What can I cancel? What does that mean? That's the whole. So over here for H, for my removable discontinuity, which is a whole, I'm going to put x minus 2 equals 0. Because I know I'm going to have to solve that. If you don't remember, in your notes from what we talked about with removable discontinuities, if any factors canceled, that creates a whole. Set that factor equal to 0 and solve for x. So that's why I rewrote it. Bless you. That means that our equation really just simplifies to x plus 2. What I do whenever something cancels and I can't use the original anymore, I just put a big X through it because I can no longer use it. This is no longer what I'm graphing. I'm now graphing y equals x plus 2. Where have you seen y equals x plus 2? What kind of function is that? Linear. It's an algebra 1 linear equation. You literally know how to graph that. So, okay, I've done the simplifying. That's done. Now I just need to find the whole. So I'm going to make x equal to 2. That's my x value. I now need to find the y. If you think back in the notes that I already highlighted, it specifically said, plug in the x value to the simplified equation to find your y. Are we going to use the original? That's why I put a big X through it. You're going to use the simplified equation. So y equals x, let me actually put the x plus 2. We're going to take this x and substitute it in. So we're going to make this y equals 2 plus 2. What's 2 plus 2? So what is the coordinate for my whole? All right, cool. We're still going to follow the rest of the steps. R stands for our roots. We're going to set the numerator equal to 0. Is there a numerator anymore? I mean, there technically is. The numerator is technically x plus 2. All of this is over 1. So in order to find the x-intercept, which is your root, you're really just doing the same thing as it's saying in the directions. Take the numerator, set it equal to 0, and solve. That's what we do every single time we find an x-intercept. So my root should be -2. Hussein, do I need to solve for a vertical asymptote? Vertical asymptote comes from where? Is there any denominator here? There is, but there's no x, exactly. So is there anything I need to solve for? So I'm going to put none. When there's no vertical asymptote, we don't need to worry about the tangent either. For the end behavior, some students will try to argue with me and say, Ms. Tapia, it's technically top heavy. Once it simplifies to a linear function, guys, that's your function that you're graphing. There is no end behavior that you need to pay attention to. So for the E part over here, I'm going to put none. And the reason why is because it's linear. It's literally a linear function or a linear equation that I'm graphing. And then the Y part is the y-intercept. Just like you would do back in Algebra 1, you're going to take 0, plug it in for x, and solve. So y is going to equal 0 plus 2. My y-intercept is going to be 2.
Why is there no end behavior?
Why is there no end behavior? Because we don't have a denominator. You even told me that. We have 1 in the denominator, but it's not going to affect my graph at all. It's just a linear equation. All right, so in purple, I'm going to graph the items that I have. I have a hole at 2, 4, so let me plot that point first. I have an x-intercept at -2. There's no vertical asymptote, no tangent, no end behavior that I need to pay attention to, and I have a y-intercept at 2. Honestly, guys, all I'm going to do from here is just continue to use the slope. So I have some points. I'm going to go, let me see, down 1, over 1, down 1, over, that's still there. I'm going to put all of my points just because I want to make an actual perfect graph. And you could have done that from the beginning, just graph this line using the slope and y-intercept, which is ideal. But I want to make sure that I included that hole because most of the time you guys will forget about it and then you'll complain, you took off points. Yes, because you forgot to put that. And then for this one, this isn't an asymptote. This is your actual graph. So using your ruler, create a straight line, solid straight line. Joseph, what's the vertical asymptote? Do we have a slant or horizontal asymptote? Do we have a slant horizontal asymptote? Do we have that?
No.
No, so I'm gonna put none. Do we have any removable discontinuities, which is the same thing as a whole? Where? Wow, Joseph, your voice has multiplied. Joseph, what's the y-intercept? Do we have any x-intercepts? Where?
Negative.
What's the domain? We're gonna write all real except what?
Except
Why 2?
that's
X value for the what? Okay, then the discontinuity is a what? What is it?
doesn't exist.
It's a whole. It's literally an empty space. So that's why we're putting all real numbers except 2, which is the X value for your whole. You can literally have all of these other points, but once you plug in 2, you're going to have an issue. You can't use that. That's literally a whole. And then for the range, I'm going to keep the range for this question because you can actually find it. It doesn't have to be Joseph. What number should you probably not use for the range? 4. Why cannot equal 4? All right. There's one last question to look at, and that's question number 5. So flip it over to question number 5. Let's see what you get. I'm giving you a head start on question number 5. See what you can figure out. I will mention, you're probably going to need the back side of this page for this question. I'm purposely leaving this up for a couple minutes so you can try to write this out without me. All right, so I'm going to give you a couple minute head start to actually start working on this. The fun part is going to be simplifying, so have fun simplifying. So I know how I am. I'm going to need the back side of this page for sure to simplify because there's way too many X's. Fatima, on the numerator, what can I factor out first? That's going to leave x squared minus x minus 20. And then what about the denominator, Fatima? An x. Okay, I still need to try to simplify. I'm going to have to factor the numerator and the denominator. So I'm going to put a little x chart at the top for the numerator. This is negative 20 and negative 1. The only two numbers that will get me those combinations is going to be negative 5 and 4. So for my numerator, I'm going to rewrite it as x minus 5 and x plus 4. In the denominator, we're still going to have x, but I now need to factor the trinomial. So negative 3 and negative 2. The only combination of numbers I can get are 3 and 1. The 3 needs to be negative. So we're going to make that x minus 3 and x plus 1. Fatima, does anything cancel for this? No, nothing? An x. One of these x's here, there's 2 x's. Do you guys agree? X squared means there's 2, so I'm going to cross out one of them, and I'm going to cross out the one in the denominator. What I just crossed out, Heidi helped me with a while back. This is going to be one of the wholes. If not, it might be the only whole. So over here for the h part, I'm going to put x equals 0. Is there anything else I can cancel here? No. Okay. So on the front side of this page, I'm just going to rewrite what I have, which is really x times x minus 5, x plus 4, all over these two binomials. All right, so I'm going to rewrite this on the front side. This is my simplified answer, x times x minus 5, x plus 4, x minus 3, and x plus 1. All right, so that part's done. And now do you figure out what the whole is? We know that x equals 0. That's fine. That's going to be the 0 for my x value, for my coordinate. I now need to find the y. Using the simplified equation, I'm going to plug in 0. So 0 times 0 minus 5, 0 plus 4, all over 0 minus 3, and 0 plus 1. The issue that I'm having here is this 0 in front. I could literally subtract 5 from 0. 0 minus 5 is 5, negative 5, and 0 plus 4 is 4. What's negative 5 times 4? 20. Negative 20. But what's 20 times 0? 0. So I don't really care what the numerator is here. When you're multiplying it by 0, your y value is also going to be 0. So it looks like we have a hole stuck at the origin. Valerie S., how do I find the roots? What do I need to do? Okay, set the numerator equal to 0. I'm going to move my SHRATEY abbreviation down some, so that way we have more room. X times x minus 5 times x plus 4. I'm going to set that equal to 0. I need to set x equal to 0, x minus 5 equal to 0, and x plus 4 equal to 0. By having this x equals 0, what do we already know is happening at 0? What do we have already? We have a hole. So I'm going to cross that out. I'm just going to write hole next to it. We don't have a x-intercept at 0 because we have a hole at that point. My other x-intercepts, I can just add 5. So this will be positive 5. And the other x-intercept will be at negative 4. For the A, for SHRATEY, I now need to take my denominator, set it equal to 0, and solve. So we're going to make x minus 3 equal to 0 and x plus 1 equal to 0. So we're going to have x equals 3 and x equals negative 1. Remember, guys, this is my third time teaching this today, so if I'm moving too fast, please tell me. T is your tangent. Jacqueline, what's the multiplicity on, really, both of these denominators? Say it again. For both of them? What's the degree for x minus 3? Or excuse me, the multiplicity for x minus 3? 1. And what about for x plus 1? You're right. So we're going to graph both of these apart, since they both have a multiplicity of 1. E stands for your end behavior. So Jacqueline, looking at what I have here, even though it's not FOILed out, what's the degree for the numerator? Say it again. 3. It is 3. 1 plus 1 plus 1 is 3. We're going to add that. Your degree is going to be 3. And what's the degree for the denominator? 2, because ultimately we are going to have to FOIL this out. That's going to help us. So you're absolutely right. Degree is 3 over 2. If you look back at the directions here, when you have a top-heavy graph, you're going to have to use long or synthetic division. On the back side of this page, I'm going to actually use long division for this because I no longer have just one binomial, I have 2. So I'm going to have to use long division. So I'm making a note, and then I'm going to switch it over and actually divide. So I'm going to make a note here also. We have a slant asymptote. So I also wrote that we have a slant asymptote right here. All right, so on the back side, I already know none of these canceled. And when we had all of these that we factored out, this is what our trinomial will look like when I FOIL this. This is what our trinomial will look like when I FOIL this. I'm not going to refoil this. I'm going to recopy these two. So we're going to have, for the numerator, y is going to equal, we're going to have x times x squared minus x minus 20 for that numerator. And for the denominator, we're just going to have x squared minus 2x minus 3. In order to use longer synthetic division, you need to have everything multiplied out. So I'm going to distribute that x to make it x cubed minus x squared minus 20x. All divided by this. Y'all know how to use long division. Y'all made it out of algebra 1. Divide it. Notice that I'm also putting a +0 at the end. You need a constant. We talked about this before with long and synthetic division. If a term is missing, put in that missing term. I'm giving y'all a head start. Try dividing it. All right, so I'm going to divide. First thing I'm dividing is x cubed by x squared. Valeria, what's x cubed divided by x squared? Just x. So I'm going to take this x, and what do I do with it, Valeria? Okay, so multiply. What's x times x squared? Okay. What's x times 2x? And x times 3? What do I do at this point, Valeria? Switch the sign. Some teachers put the negative and then a parentheses around it. I'm weird. I just like to switch every sign as I see it and cancel it that way. When you cancel it, guys, make sure if you can't actually subtract these and cancel it, you can't continue. You have to make sure that you have opposite signs for both of these first terms. -1 plus 2 is just x squared. -20 plus 3 is going to give me -17x. This is why I had that 0. Put that 0, bring it down. From here, we're going to do one more time. I'm going to take x squared and divide it by this x squared. So x squared divided by x squared. Is that 0? What's x squared divided by x squared? 1. I was like, please don't tell me 0. Technically, once you get to this point, you're done. Because does the remainder matter at all? No, we talked about this on the last couple questions ago. The remainder doesn't matter. This is our equation. So once you get to this point, I'm fine if you stop. I'm going to flip it back to the front side of my page, and I'm going to rewrite x plus 1. I don't care what it looks like when you multiply all of these by 1. It's not going to change the equation. So on the front side for my slant asymptote, y is going to equal x plus 1. The last thing that I need is my y-intercept. Wait a minute. Since your y-intercept, or excuse me, one of your x-intercepts is at the origin, what does that mean for the y-intercept? It's 0, which means that, can you actually graph that? No, because it's a hole. So I'm going to take all of this information and graph it. And after we're done, I'm going to label all of the pieces to the side, and then we're done. Okay, so in this middle part, let me start with the beginning. Ask this to simplify. There's nothing to simplify. The origin is a hole, so I'm going to put a hole in blue. I have no root at the x-intercept for 0. We have x-intercept at 5, x-intercept at -4, and I have 2 vertical asymptotes at 3 and -1, which I'm going to draw in pink. So 3 and -1. And again, both of these are going to be apart. We have a slant asymptote at 1, y equals x plus 1. So when you graph that slant asymptote out, I'm not going to graph everything in the middle, because remember, the middle part is not affected by what's happening to the ends of your graph. So if you take a second and look up, for y equals x plus 1, I know that the y-intercept is here. I'm going to go up 1 over 1, up 1. Let me try that again. Up 1 over, up 1 over, up over, up over, up and over, all the way out. Notice that I'm not drawing anything in the middle. If you need to draw stuff in the middle to see what the graph looks like, I'm fine with it. But I shouldn't see for your final answer a graph for your slant asymptote in the middle. From 1 again, I'm going to go down to the left, down to the left, down to the left. And I'm going to graph this line for me. I'm going to graph it in pink because that's what color I chose for my asymptotes. I just wanted you guys to see what points I was using. And since this is a slant asymptote, I'm going to dash this line.
We joined the middle.
Because this is for the E part of your SHRATEY, and SHRATEY only defines what's happening to the ends of your graph. End behavior only affects the far ends, left and right of your graph. It doesn't affect what's happening in the middle. Is that okay? Okay, for the purposes of time, I'm going to help you guys with identifying what's going to happen in the middle, but you guys need to at least tell me first. How do I find out what's happening in the middle? What do I need to use? Test points. So you would need to use test points. Jenny, what are some good test points to use for this? +1 and what else? -1/2. Perfect. Those are the two ones that I used. So on your tests and quizzes, guys, you would have to do it, but I understand we're almost done. X equals 1, you're going to get a positive answer. For x equals -1/2, you would get a negative answer. So graph that out. Show me what that middle portion should look like.
So do we still apply the 1 as the y then 1?
This is saying when your x value is 1, what is your y value going to be? So if the x value is 1, you're going to use the equation that you have here, not the original. You're going to use the equation we have here to simplify. When you simplify all of this stuff with +1, you're going to get a positive answer. That means that if I was to graph this function, it would be somewhere up here when I graph it.
Oh, so use the whole for it?
Mhm.
Because what I was thinking was like for the previous question that we did, we use it by like using the y-intercept in the middle.
So in the last question, we didn't have a middle section. For this middle section, remember, that's going to be the only like new part to your graph. That's the only new piece. It's going to be either a linear function in here, a quadratic function, or a cubic function. So far, this graph is looking like it might be parabola or it might be cubic. Once I graph this part, which is where x is -1/2, it's going to curve down this way to approach the other side. So it looks like it's going to be a cubic function. It's going to be a little ugly, but it works. The last thing I need to graph out is what's happening when it's apart. Okay, from the right-hand side over here, it's going to need to be apart, so it's going to have to go down this way and then kind of curve this way. And then for the other side here, this part's going down. Okay, so I need to go through this point, so it's going to have to go up this way. And then it also needs to get close to your asymptote. So it's going to look something like that. It's not the most beautiful graph, but it'll get you credit. Points for points. All right, so I removed the range so I could just add this stuff in so that way we can get this part done. Odalis, what's the vertical asymptote for this? Okay, do we have a slant asymptote? Yes or no? Okay, and what's the equation for that? Removable discontinuity means a hole. Do we have a hole here? Where? Do we have a y-intercept? Be careful. No, we don't. There's none. What about an x-intercept? Okay, we don't use the origin, but what can we use? And for the domain, we're going to write all real numbers except what? That's it? Is that it, Odalis? You're right with the vertical asymptotes, but don't we have a hole for this? And 0. Your removable discontinuity is dealing with the same thing. It's going to include all of the holes that you have, all of the removable discontinuities, along with whatever's happening in your denominator. So your points of discontinuity would just be 0, -1, and 3. Those are the values where your graph will be undefined. Because remember, points of discontinuity, points of discontinuity is where your graph is undefined. Questions or concerns about this?